Hi, we're going to talk now on how to do in Chapter 4 for the Operations Manager Management course, Problem 4, which is on page 139. Now, that has a little bit difference because it has 9 work centers, but before we worry about that, I want to walk through how to do these problems. Basically, what these problems are is as a manager, there are going to be times that you need to figure out where is the most efficient location to stage different processes. Now, these by themselves are very simple, and students have a terrible time with these because they're confusing the first time or two through these. So what we're going to do, if you'll turn to page 130 and 131 in your textbook, we're going to walk through this problem. So just bear with me here, and we're going to walk through this together. Now, first of all, I've copied in some data already on here, so you don't need to watch me type. But if you'll notice, my very first thing I have on here is what I call a from to chart. And this is taken identically from the top of page 131. And I typed this information in there exactly like it shows in the textbook. So what is a from to chart? Basically what this is saying is the number of trips on an average day or hour, whatever it may be, but what the number of trips are you're going to make from one location to the other. So think of this like a McDonald's, if you will, like a fast food restaurant. So in a typical, let's say, hour, how many times does the salad sandwich part interact with the grill? So if I look here, if you look at my cursor here, it's showing that my salad sandwich is going to operate with the grill, so I can come across and go up to grill, and it's 10 trips back and forth between my salad sandwich and the grill. Between the counter and the grill, I have 40 trips back and forth. Between the counter and my salad sandwich, I have 15. Between the drinks and the counter, I have 60. Between my order assembly, I go across on there. So it tells me how many trips I'm going to have back and forth through here. For example, from the drive-through to the order assembly, I have 10 trips. From the drive-through to the drinks, I have 50 trips a day through here. So it means when you're setting this up, obviously, you're going to want to have the processes, in a sense, that talk back and forth to each other the most closest together. I mean, that just makes common sense. That if I am, think of an office, if I'm in an office and I have people that print a tremendous amount of times in a day, I'm not going to put them clear on the other side of the building from the printer. I'm going to have their cubes or their offices right next to where the printer is. On the other hand, I may have someone in senior management that rarely prints things, and he'll have administrative assistants do those and bring to him. I wouldn't necessarily put him right next to the printer. So this is really what we've done here. We're just laying out how many processes I go back and forth through here. Now the second part of this is I put a little section here called my stations. Now this doesn't really talk about this on page 130 and 131, but the stations, if you look in your homework assignments and things like that, they'll have stations with letters. Again, this confuses students to the nth degree. Think of this as nothing more than locations. In other words, in my fast food restaurant, I have 6 different work areas. And these 6 work areas are lettered A, B, C, D, E, and F. And where they're located at, and you could think of these as buildings, you could think of these as cubicles, whatever you want to think of on here. But I'm in a fast food, so we're going to say there's 6 different potential workstations. These stations are just the letters are just the name of what these stations are. And then it's how far the trip is between. So I come over here and I show my distances, my basically the steps, you would say, in between. So from station A to B, I have 1 step. From station A to C, I have 2. So in other words, I start here, I go 1 to B, 2 to C. If I come down here, I go A to D equals 1. So I go A to D is 1. A to E is 2. A to E is 2, so because I could come here 1, 2, or I could go 1, 2. Now, A to F, and I didn't put these in here, but I'm going to go ahead and put these. Oh, let me drag this on down here a little bit. I guess I did. Okay. So in other words, A to F, and C to D are clear on the other sides here. These are going to be 3 steps. So if, let's say I want to go to F, I start at A, I can go 1, 2, 3, or I can come down here from here and go 1, 1, 2, 3, 3 steps. The same from C to D. It's 3 steps in between here. Let me go ahead and just put this C to D equals 3 steps. Okay? So that should make some sense to you how this works. If I go B to C, it's awfully 1 step. B to E is 1 step, so forth and so on. Make sense to you? Just think of the number of steps in between there. Now, when that's done, you're going to come in here, and so I made a little cheat sheet here how to do this. First, you create your from to chart. Now we're going to pick out step 2 is pick out a layout of where we want to put our processes. Notice up here I have 6 different processes. I'm grilling, salad sandwiches, counter, drinks, order assembly, and drive-through. 6 different ones of these. In which of these 6 stations do I want to put these 6 processes? That's what we want to figure out. We're going to use what we call a load distance formula, and we want the lowest number to figure that out. So what we're going to do is we come in here and we have layout 1. This is purely arbitrary. You could pick totally subjective. You pick whatever you want on here. What I always suggest doing is look to see where the most number of trips are and try to get those close together. So for example, my drinks to the counter on this one show 2 apart. Another one on here is drinks to drive-through, show 2 apart. So this may not be the best layout, but I've just grabbed some things to put in here. So what I'm saying is then, so in station A, I'm going to put my drive-through. In station B, my salad sandwich, C, my drinks, D, my grill, E, my counter, F, my order assembly. I only show the station letters up here to help me with my distances. So arbitrarily then, I'm plugging these in here. Now, the second part of this is to do the table that I call the distances between processes for my layout. Now, they have them on there on the bottom of page 131. They show both layouts on here. I don't like to do that. I find it confusing. So I have distances between my processes for my layout number 1. So how do I do this? I look right up here in this section. I copy my table down exactly, my headings, exactly like I have up above. Notice that this is a critical thing on here. Your distances between the labels coming down in the rows and the labels going across in the columns must match exactly. And this will make sense to you in a second on here. So what I'm going to do now is I'm going to come in here. So I've got my layout 1 that's just arbitrarily done. And now I come down here to my distances between processes for layout 1. So I'm going to start right here at the top. So I'm going to go grill to grill. Well, obviously I'm right there. So there's 0 steps. Next I'm going to go my salad sandwich process to my grill. So I come up above here and I find my salad sandwich. There it is right here. Then how many steps would it be, or distance or whatever, here we're talking steps, between my salad sandwiches and my grill? I can't go catty-cornered, so it would be 1, 2. So I enter a 2 in here. My next label down is counter, and I go counter to grill. So how far is it from my counter to my grill? So I come up here and I look at counter, and I go to find grill. It's 1 step, so I enter a 1 here. I also look at my counter to my salad sandwich. My counter to salad sandwich is 1 step. And now I come down here because that's my next item down are drinks. And my drinks I'm showing to the grill, from drinks here to grill, drinks to grill. See how that works? Drinks to grill. So up here is drinks. Over here is my grill. To get there, I'm going to go 1, 2, 3. So for my drinks to grill is 3. From my drinks to my salad sandwich, I come up here, I go drinks, and right next to salad sandwich, that's 1. And now I go drinks to a grill, drinks to grill, here's drinks, here's grill, that's 3. Drinks to salad sandwich, next door is 1, and so forth. Fill all this out all the way down through here. Basically, again, come down here. So if I want to say how far is it from the drive-through to the counter, what's my distance the way I have it laid up? I come in here and I go counter to drive-through is 2 steps and fill that out on here. Now, in the textbook on page 130 has this fancy formula for you. It's called equation 1. And I'm sure that's a little overwhelming for you. In all honesty, it is for me too. What this is simply saying is this, is we're going to come now, and I've got two different charts here. I got my from to chart with numbers in it, and I got my distances between processes. So what I'm going to do, the load distance system or formula basically says take the number of trips between a process and multiply it by the distance, and then add that up for each one of those all the way through here. So in other words, I would come in here and I go, my grill to grill is 0 to 0. I'm going to add to do that my salad sandwich, so I'd have 0, and I would take 10, because I have 10 different times I have to do this from my salad sandwich to my grill, and it's 2 steps. So I'd have 0 plus 2 times 10 is 20. Then I would go plus 40 times 1 plus 15 times 1 plus 3 times 0, so forth and so on across. It's very complex. You can look at that formula on there, and it steps you all out through it step by step on there. Here's a really simple way to do this, folks, is if you come down here and you look on column or row 36, my formula here, and I'm going to click in my formula cell here, 445. If I click in this, this puts a different formula in here. It's what we call the sum products. And what this basically says is if I go equal sum products, I'm going to take this range, which is C7 to H12. I'm going to take each of the individual cells in this range. I'm going to multiply each cell by the corresponding range cells down here and then add it together. Sum products. I'm going to sum up my products. And I come in here. Now, what I did do on this was make my from to chart an absolute reference. So when I do another layout, I don't have to highlight those again. I can just copy and paste them down through there. Let me show you what I mean on that. So here is my answer on this, my sum product. What this is saying basically is if I came over here and I took C7 times C28, added to that C8 times C29, multiplied 40 times 1, add to it, 15 times 1, add to it, 0 times 3, 0 times 1, 60 times 1, or 2, so forth and so on. You can write all of this out. It's extremely intensive. This is a simple way to do it. Again, it's a sum product, and it's so easy to do. But notice, so I've got 445 for my score here. So now I'm going to come down and I say, well, what would be another option? So now I'm just going to do layout 2. And on this, I come in and I think to myself, well, let's use a little more common sense here. So since when I look at my from to, I notice my counter and my drinks again are 60. When I come to layout 2, notice that my counter to the drinks are moved down a little bit. Well, actually, so the text shows you a second example there. They call that layout 2, and they've come in and they've tried to improve on this by moving some processes closer together. And as you can see, they did the same thing again. So we come in here, we do our distances between, and we just come through here from grill to grill. Of course, is 0. Salad sandwich to grill is 3 steps because where they have it located here. So I got salad sandwich to grill. Opposite corners is 3. And again, like we've done before. Now they come down here, and we enter in a sum product again. So again, I'm going to take my sum product. I'm going to take my from to chart that I created first, because that never changes. The number of processes between never change. And then I'm going to multiply that by my second layout, my new layout, which is C44 to H49, this area through here. Well, this gives me a load distance score of 440. So this is indeed better than the 445. However, the textbook doesn't show this, but I did a third layout on here. That, to me, makes more sense. And what I did on this is I went back to my from to table, and I tried to find the largest processes that were back and forth. So if I look back up here at the very top, I'm scrolling up to the top here, and I show my processes, what's the largest two processes I have in here? I have my drinks to the counter is 60. I have my drive-through to the drinks is 50. And my counter to the grill is 40. But my top two are drinks to counter and drinks to drive-through. Both are 60 and 50. When I come down here and I look at my layout 3, I've got drinks to drive-through and drinks to counter next door to each other. So they're only one step away. And then I went ahead and populated him trying to find the largest distance. This is where the subjectivity comes into this. You want to just look for processes that are and put them the closest together, and it's a trial and error. So since I've got this set in a formula, it's very simple to do. I lay out my new layout. I come now and change my distance table here. I come in and I do my sum products, taking this array, my distances for processes 3 times my original from 2. So if I look on here, here's my sum products from 2 to the new array, gives me a layout of 390. So obviously this makes a lot more sense than what the textbook is. I don't know why they didn't put that in there, but this, you can see how you can improve on this. So that's really all you do. Let me go over this one more time on here, the steps on this. First, you're going to create your from to chart. And you can lay this out. It doesn't matter how you do this as long as you do it the same way for both your from to and your distances between. Again, this is the number of activities. If it was trucking, it could be loads. It could be all kinds of different things on here. Interaction between offices. It's if manufacturing, it could be how many times do I go from the paint shop to the supply room, or how many times do I go from the lumber pile to the saw room, or something like this. And you obviously want to put those closest together. Now, with all of that said, there are times that you've got to make the best of what you're given. For example, your problem 4 has a 9 spaces to put processes in. It has 9 different spaces. But if you look in that, and if you look on page 139 and 140, but particularly go to 140 on table 4.7, you'll notice there that they're saying in section or in rooms or locations of A, C, G, and I, you are already told what processes have to go there. Now this could be because it's just the size, whatever it is on there, something like that. If you think about that in an office, let's say that you have a big conference room, and you have where you want to put a conference room. So you have a room that's large, and then you have smaller offices. Well, you wouldn't put the conference room in a small office. You would say this has to go here, and then you would load around the functions the closest to that. So in table 4.7, it's saying in location A, I must put process 1. In location C, I must put process 2. In location 3, I put process 3. In location G, I put process 3. In location I put process 4. Again, do not let the letters confuse you in the numbers. The letters are simply the names of locations. This could be the Apple office. It could be the ball office, the cat office, whatever it is on there. And those are just names of offices or names of locations that you just mark in your company. And then you're going to say what teams or what processes will go in there. And you come in and this is like we've done before. So you do your from to chart. You pick out a layout that's totally subjective. Again, I suggest you start with your largest activity. You create distances for your processes and use your sum product. I've also included on here, if you're scrolling down to the bottom, I did the solve problem on page 136 to 137. It's very similar to the one we've just done, but just notice how it has a layout a little bit different across on here. But here's my from to chart. Here are my stations. I call them A, B, C, and D, and A, B, C, D, E, and F, exactly like they do in the textbook in table 4.5. And then I come in and just arbitrarily grab some different functions on here, and I show my LD scores on here. I also did chapter 5 problem for you, and work that out as well on here. So you have several examples on here. But the key again is laying out your from to and your distance tables laid out identical with your headings. If you have any questions, let me know. Thank you.